Welcome to the Deep Dive. Today we're tackling a really fascinating piece of research. It gets right to a core challenge we all face. Really, how do we make sense of just the sheer amount of text data out there?
It's overwhelming, isn't it?
Exactly. So we're exploring a system that uses some, incredibly smart natural language processing, NLP, to pull out actual usable insights from, the places like policy documents, even CVs.
Right, unstructured text, basically.
Think with it as a way to automatically understand the key skills being discussed, how those skills link up with actual jobs, learning resources, and even how they connect to global sustainability goals.
It's quite ambitious, yeah.
Yeah. So our mission in this deep dive is to figure out exactly how the system works, what its potential impact could be, from shaping policy to maybe guiding your own career. We've got a bunch of different source materials the system looked at, so let's jump in.
What really grabs you first about this paper is, I think, its ambition to build this seamless end-to-end process for extracting meaning. The basic problem, like you said, and the paper points this out too, is we're just drowning in text. Policy, education, employment.
Everywhere.
And we desperately need better tools to find the important stuff, the signal and the noise, And this system tackles that head on. It automatically pinpoints skills mentioned in documents and then connects them to real-world jobs, relevant courses.
Okay.
And what's really striking is their validation. They show it can do this with accuracy that's, very close to a human expert.
Wow. Okay. So let's try and picture this system. It sounds like the text goes on quite a journey. Multi-stage, you said.
It is, yeah. Pretty detailed.
Yeah.
So step one is all about prep work, extensive pre-processing and cleaning up the data.
Right. Getting rid of the junk.
Exactly. Think about all the different formats documents come in. You've got HTML from web pages, PDFs, Word docs, plain text files, even XML sometimes. All sorts. And the system uses specialized software libraries for each one. It basically strips away the visual clutter formatting, footnotes, citation markers and papers, all that stuff, just to get down to the pure text.
Makes sense. Clean input, better output.
Precisely. If you want good insights, you need clean information to begin with.
So once the text is all spick and span, what's next?
Then comes a really cool part, semantic embedding and segmentation. The system breaks the clean text into smaller, meaningful chunks.
Okay.
And for each chunk, it creates this sophisticated kind of digital fingerprint. They use something called sentence transformer for this.
Sentence transformer? Okay.
Imagine taking a sentence or a small paragraph and turning it into a list of numbers, a vector that captures its meaning in a really nuanced way.
So it understands what the text means, not just the words.
That's the idea. It lets the system compare different bits of text based on semantic similarity, how close their meanings are. And to keep things running fast, they use some clever tricks like caching these fingerprints so they don't have to recalculate them constantly.
Smart. So we've got these text chunks turned into meaning vectors. How do we get from those numbers to spotting actual skills?
Okay, this is where a technology called FAISS comes in, FAISS. It's used for similarity search.
SAS, like a search engine for these vectors?
Kinda, yeah. Think of it like a super fast librarian for these meaning fingerprints. The system already has a library or index built from the ESCO framework.
ESCO?
Yeah, it's a European standard classification of skills, competencies, qualifications, and occupations. So it's a big standardized list of skills and jobs.
Gotcha.
Each of those ESCO skills has its own meaning fingerprint in the library. So when the system processes a chunk of text from a document, it compares its fingerprint to all the skill fingerprints in the ESCO library.
And looks for matches.
Exactly. It uses a measure called cosine similarity, basically. How well aligned are the two fingerprints? If the score is above a certain level, a threshold they can tune, it flags it as a potential skill match.
Okay, but I imagine one document might talk about, say, project management in a few different ways.
Precisely. Good point. So after that initial matching, the system does a sort of frequency analysis. It looks at how often each potential skill pops up across all the chunks in the document.
To see which ones are really central.
Right. It helps confirm the importance and avoids just counting slight variations over and over. And there's also a post-processing step to clean things up further, removing near duplicate skills that are basically the same but maybe phrased a tiny bit differently.
Okay, so now we've got a solid list of skills extracted from the document. How does it then connect these to, say, job titles or courses?
For occupations or jobs, it uses a couple of methods. First, it checks how many skills needed for a specific job, according to ESCO again, are actually present in the list of skills it just extracted from the document.
Like a checklist.
Sort of, yeah. An overlap ratio.
Yeah.
Second, it looks at the overall textual similarity between the entire document and the official description of that occupation.
Ah, okay. So content similarity too.
Right. These two scores get combined into a composite score to rank the occupations. So it suggests the jobs most relevant to the document's content.
And for courses, similar idea.
Very similar, actually. It's like the skill extraction part. They have another library, this time, of course, descriptions. Initially, they use sources like SDSN, but they're expanding it to include AE4RA resources, too.
AE4RA, right.
The system takes the skills it extracted from the document and searches this course library using FAISS again. Courses whose descriptions have a high similarity score to the identified skills get recommended.
And you mentioned SDG analysis earlier, Sustainable Development Goals.
Exactly. The system also creates one overall meaning fingerprint for the entire document. Then it compares that fingerprint to pre-existing fingerprints for each of the 17 UN SDGs.
Using cosine similarity again?
You got it. That generates a relevance score for each SDG, showing how much the document's content seems to align with that particular global goal. And this gets shown visually.
Which leads us to the interface. How does a user actually see all this?
Yeah, the final piece is this interactive web interface. It's built using tools like Dash and Plotly, which are great for creating data visualizations.
Charts and tables.
Exactly. Users can explore the skills that were pulled out, see bar charts of the top matching jobs, get a ranked list of course recommendations, and see the SDG alignment visually. It's designed to be pretty intuitive, letting people explore the results in real time. The aim is to support better decisions, really.
Okay, so pulling back a bit, what makes this whole approach stand out? I mean, automated text analysis isn't brand new, is it? What's the leap forward here?
That's a fair question. I think the real significance is in how comprehensive it is. It's not just picking out keywords like older systems might have.
Right.
It's trying to truly understand the meaning, the semantics, and then crucially, it directly links those insights to established career pathways like ESCO and to educational resources, especially those focused on sustainability like SDSN or AE4RA.
Does the end-to-end connection that's novel?
I think so. That integration, from messy raw text all the way to actionable recommendations tied to recognized standards. It really addresses the limits of traditional skill extraction, which could be slow, expensive, very manual, prone to bias. By using these advanced embedding techniques like sentence transformer and the speed of FAISS for searching, they achieve huge gains in how much text they can process and how fast they can do it.
The paper mentions previous work too, things like resume parsing or skill matching tools. How does the system compare?
Well, those tools are definitely valuable, especially in HR, right? But this research seems to aim for broader applicability, not just resumes, but policy docs, curricula, potentially other things too.
More general purpose.
Exactly. And potentially across different languages down the line. Because it relies on embeddings understanding meaning rather than just keyword spotting, it should be better at handling different phrasing and nuances. And they do mention that advances in large language models are also helping with understanding complex skill descriptions.
Okay, so if we had to boil down the core impact for someone listening, how does this help them cut through the noise, go from that pile of text to something useful?
Well, essentially, this system acts like a translator. It takes this like overwhelming, often messy world of unstructured text and turns it into organized, practical knowledge.
Right.
So if you're a policymaker, it might show you which skills are really relevant for, say, a new green energy policy. If you're running training programs, it could highlight the skills needed for emerging job roles.
And for individuals.
For individuals thinking about their career, it could map out potential paths and the specific learning needed to follow them. By knitting together these sophisticated semantic methods with established frameworks like ESCO and course databases, they've built a really powerful bridge between raw information and actual opportunity. It gets right back to that idea you mentioned quickly, but thoroughly understanding complex stuff and seeing the bigger picture.
And the validation results you mentioned earlier, near human accuracy. That sounds pretty incredible.
It really is. Their validation was quite thorough. They used synthetic documents, ones they created specifically for testing and real-world examples. And they looked for skills that were explicitly mentioned, spelled out.
Obvious ones.
Right, and also skills that were implied by the context, which is much harder.
Definitely.
And the scores, they got F1 scores, which balanced precision and recall were over 0.95 for explicit skills and over 0.93 for implicit ones.
Yeah.
That's remarkably close to human performance.
Wow.
They carefully measured how well it found the right skills, recall, without flagging too many wrong ones. Precision. It suggests the system can uncover competencies that might be missed by just skimming or using simpler methods.
It's fascinating to think how far we've come, thinking historically, what were the big steps that led to being able to build something like this? It wasn't always possible, right?
Oh, absolutely not. The journey of automated text analysis is, well, pretty interesting. Early days were dominated by very simple techniques, basically keyword searching, count how many times Java appears in a CV, that sort of thing. Very limited. It missed context, nuance, different ways of saying the same thing. A huge leap forward came with word embeddings, things like word2vec, around a decade ago.
Word2vec, right. Heard of that.
Yeah. These allowed computers to represent words not just as symbols, but as points in a sort of meaning space. So king and queen would be closer together than king and cabbage. Perhaps as semantic relationships.
Okay, that makes sense.
Then came more advanced contextual models like Burke and its relatives. These were revolutionary because they could understand a word's meaning based on the words around it in the sentence. Context matters hugely. SentenceBERT, which this paper uses, built on that to create meaningful vector representations for whole sentences or chunks of text. And finally, you need tools like FAISS. Without efficient ways to search through these massive vector spaces, real-time analysis on large data sets just wouldn't be practical.
It really puts it in perspective. Trying to do this kind of skill extraction or policy analysis manually sounds painful.
Oh, it was, and often still is.
Yeah.
Extremely manual, time-consuming, very subjective depending on who was doing the reading. Imagine manually combing through hundreds of policy docs trying to find mentions of digital literacy.
Yeah, no thanks.
This automated approach is just a massive step up in efficiency and scale.
So let's crystallize the key advantages again if you had to list the top benefits.
Okay, first, massive efficiency gain with large text volumes. That's huge.
Right.
Second, it provides structured, actionable insights by linking text to recognize skills, jobs, and courses. Connects the dots.
Okay.
Third, that near-human accuracy in finding skills makes it reliable. You can actually trust the output, mostly.
Good point.
Fourth, adding the SDG analysis brings in that crucial sustainability dimension, which is increasingly important.
True.
And finally, the interactive visualization just makes it much easier for people to actually understand and use the information effectively.
And thinking about the real world, who benefits most? We touched on it, but let's spell it out.
Well, policymakers, definitely. They can make more data-driven decisions on workforce development, figure out the skills needed for policy goals like the green transition or digital transformation you hear about, and check SDG alignment.
Okay, policymakers. Who else?
Educators. They can use it to design curricula that match real-world school demands, connect students to the right training, bridge that gap between education and employment.
Makes sense. And businesses. HR.
Absolutely. For HR folks and employers, it could really streamline recruitment by identifying candidates with the right skills more accurately. Also help spot skill gaps in their own teams for targeted training, aligning internal development with what the industry needs.
And maybe individuals, too.
For sure. Individuals can get insights into what skills are actually in demand, find relevant courses, and maybe plan their career paths more strategically.
This is really impressive stuff. It feels like we're just scratching the surface of what these kinds of AI systems can do for understanding information. Which brings us nicely to our novel notions segment. Based on this paper, what kind of, maybe slightly out there, future research ideas could spin out of this?
Okay, novel notions. Well, one direction that comes to mind is something like hyper-personalized learning ecosystems.
Hyper-personalized? Okay, tell me more.
So imagine extending this system. It doesn't just recommend existing courses. What if it could dynamically generate a completely personalized learning pathway?
Generated? How?
Based on the skills it identifies you have, the skills you need for your specific career goal, maybe even adapting to your preferred learning style.
Learning style? How would it know that?
Well, maybe inferred from how you interact with online platforms or, looking further out, maybe even brainwave data from wearables during learning sessions. Business sci-fi, perhaps?
Whoa, okay. That's definitely novel.
But the core idea connects. Right? It builds on the skill extraction and course mapping. The non-obvious bit is tailoring the entire journey, content, mentors, projects, to optimize how quickly and effectively someone learns.
So platforms like Coursera wouldn't just offer courses, they'd build your unique roadmap.
Potentially, yes. They become intelligent learning guides. The impact could be huge for workforce adaptability, but obviously big ethical questions there too.
Yeah, inferring learning styles, potential bias, definitely things to consider. Okay, what's another idea?
Another one could be predictive policy impact analysis through skill demand forecasting.
Okay, forecasting skill demand before a policy happens.
Exactly. Imagine using this system to analyze proposed policy documents, draft legislation, that sort of thing. By looking at the language, could it predict potential shifts in skill demand across different sectors?
So like an early warning system for the job market?
Kind of. It connects the NLP policy analysis we've been discussing with economic forecasting and labor market analysis.
How does that build on the paper?
Well, the paper already analyzes existing policies for skill relevance. This pushes it into prediction. The non-obvious part is providing that early warning, predicting skill shortages or surpluses before they hit, allowing governments or educators to react proactively.
So if a big green energy bill is proposed,
the system might forecast a spike in demand for, say, solar technicians or grid specialists, giving time to set up training programs.
That could be incredibly useful for planning.
Potentially, yes. Real-world impact could be better economic planning, smoother transitions. But again, challenges exist.
Like what?
Well, the predictive modeling needs to be really robust. And there's a risk maybe of policymakers tailoring language just to get a desired forecast, game the system. Plus, the political complexity of actually using such forecasts is another hurdle.
Fascinating possibilities, though, both really thought-provoking directions. It really underlines the value of the system we've dug into today for making sense of complex information and getting insights we can act on. For anyone listening who wants to explore the nuts and bolts of the system further, we'll put the link to the research paper itself in the description below. Definitely worth a deeper look if you're interested.
Agreed.
It really makes you think about how AI is evolving, doesn't it? Its role in just helping us discover and share knowledge seems set to grow and grow. Thanks for joining us on the Deep Dive.